started. This talk is about how to work with Arduino and JavaScript. So how many of you have worked with Arduino, Raspberry Pi, or Internet of Things before? Okay, some of them. So what language you used for that? JavaScript? Wow. Okay, anybody else? C, C++? Okay, so just to, the main purpose of this talk would be to get interested you in the Internet of Things, Arduino, Raspberry Pi, what these microcontrollers, microprocessors are, how to work with it, and what kind of projects you could build with it, and that all happens with JavaScript. A little bit about myself. My name is Anmol Agrawal, and actually I'm a designer, front-end developer, and evangelist of PubNubs and Littlebits, which I'll be talking about what both of them do. And you can follow me up on Twitter. That's my Twitter handle and my GitHub profile. And the main motive of this talk is to just give you an idea of what Internet Things can do and what's possible with it, and get you guys interested in with it. And because just to give an idea, as Leonardo DiCaprio said in the Inception movie, that it's impossible to eradicate an idea once it's right in there. Just a short story, like how I got interested. Actually, I'm a bachelor's in mechanical engineering, but I do design, development, and now electronics. So I would like to show you a video about this Makey, which actually fueled a spark in me to work with IoT. Do we have an audio?
There's a jack, I think, hanging on the other side. Hi, I'm Jay.
And I'm Eric. We're graduate students at MIT Media Lab.
We have a dream that everyone is an inventor. So we created Makey to let you invent just by alligator clipping. Alligator clips stuff like bananas to your Makey. When you touch the banana, your computer just thinks you're touching the keyboard. The front has arrow keys, spacebar, and mouse left click. When you're ready for more, flip the Makey over and you've got more keyboard keys and support for the mouse. You can even use the board like an Arduino when you are ready. No programming, no breadboarding. You don't even have to install software. Just plug it in USB.
Order your Makey today and start changing how the world works.
So that was a video after which I got really interested into what Internet of Things is and what can we do with it, and that's how I got started. And so you may ask, like, what is Internet of Things? And there are numerous of definitions of what it could be, but I think the simplest definition I can give is anything whether it's living and non-living, having an on and off switch device with the internet. So just like right now the concepts of smart homes and smart devices are coming up. So take an example of the smart home. Your home knows that you are coming back from the office, so it wants the lights and fans to switch on automatically, and maybe get your coffee maker turn on automatically. So these kind of things where even the non-living things talk to you and understands you, that's what Internet of Things is. But why is JavaScript? Means if anybody has been into Internet of Things and programmed Arduino before, usually it has all started with embedded C or C++, but JavaScript, as it said, that any application that can be written in JavaScript will eventually be written in JavaScript. And for more reference on that, you can visit that link there. And advent of NodeJS was a game changer for the whole development world. And JavaScript supports modular programming because of the node packages and the writing style that we adopt. And simply, I love JavaScript. So that's another reason. If you Google JavaScript and Arduino right now, three libraries would pop up. And although there are more, but I have chosen these three because of the factors like which libraries are currently very active, and they have a huge number of followers and contributors. And these three comes up. One is Salon.js, Node-RED, and Johnny5. So let me go a little bit in detail what these three do actually. So the Salon.js, Salon.js, if you visit the website, it says the JavaScript Robotics bio command. And if you go through their platforms, what it supports, you can see it can work with drones, Arduino, the Bluetooth, and Intel Galileo, Leap Motion. So these are different kinds of microcontrollers and processors for different purposes. And second one is the Johnny5. Johnny5 is also JavaScript it's an IoT programming framework. And if you scroll through them, you will find that they have for sections called board, LED, working with LEDs, servos, motors, stepper motors, pretty much all the things, almost all of the things in the electronics that you can find. And thirdly, there's the Node-RED. Node-RED is a visual tool for wiring the Internet of Things, and you can consider it as the Scratch programming with the Internet of Things. How many know Scratch? Okay, so Scratch is a project by MIT Media Lab where it enables students, kids under like 8, 10 years old to learn the programming language through drag and drop. So, this is what Node-RED does for the Internet of Things. I'll be showing you a couple of demos, and they are going to be very basic, taking you through the baby steps of how to program and write programs and run it on Arduino. And I'll be showing the examples with the LEDs. And LEDs, because they are a very simple component, it's just a light. You can turn it on and off. You can there comes in different colors, and you can even make it blink in a pattern like Morse code or something else. And being the simplicity means you can achieve a lot of complexity, which we'll see right now. I would like to tell you one of the companies that I'm evangelist of, Littlebits. And Littlebits, let me try to show you live what it can do. So here I have the little. just doing this all live. And here you can, let me just try. Okay, so this is the power module, and it's connected to just a battery. And here is a slider trimmer. So these are the electronic components which stick together using magnets at the end. And so what it enables is you to build this circuit instantly. So there's no breadboarding, no wiring, no soldering. So that's the first thing. Second thing you can notice, they are color coded. So blue is the power, pink ones are the sensors or the inputs, and here's the green one, which is LED. Here's the bar graph, and they are the outputs like motor or servos. And they can also run without code. So if I just turn on this battery, and if I just do it. So I'm just sliding the dimmer, and the bar graph, it changes color accordingly. So it's happening without code because every element has their own default behaviors. But we can also run the code through that. It's based out of New York. So actually, I have got my whole kit of little bits. If anybody wants to try out or see what kit can do with it, so just feel free to reach me out. And let's try starting some demo. So you might wonder what would be the hello world of the Internet of Things, and it's actually just blinking an LED. It's as simple as that. Let's try to, let me just run through the code, how it works. Okay, so in these examples, I'm using Johnny 5, and just like in the normal JavaScript program that you would write, first we have we'll mention whatever the modules we require. So here's this Johnny 5. Inside the Johnny 5 library, there's a component called board. So it essentially means whatever the board you are using. Here in this case, we have the Arduino board. And we are saying that when the board is ready, we are executing this function, and we have defined an LED inside it. And LED is set on the this pin number 5 of the Arduino. And here's just the REPL we have injected, because like from the command also we can control this LED. And then we have executed the LED that one of its methods is blink, and we have said that it should blink every 1000 milliseconds. That's 1 second. And if we run the video of that, so yeah, I'm just showing how the circuit looks like. So we have the power, blue color, orange is the Arduino, and green one is the LED. And because it snaps up, there's literally minimal amount of wastage of time in building circuits. And here I'm just running the program with the node. So once it's connected, if you see this side, the LED starts blinking out of it. And that's how simple the hello world is. The next example is about controlling the LED, because everything is not blinking. We have we control things, whatever. So like the smartphones and all those things. So we want to control it in a way. So let's take a simple example of controlling the LED with a button. And looking at the code of it, it's almost similar as the last one, but only addition is the button inside the this board block. We have the new button defined, which is connected to the A0 pin, which is the analog pin in the Arduino. And we have just said that if the button is hit, like it's pressed, the LED will turn on, and if the button is released, LED will turn off. So the logic is as simple as you would think and see in the real world. If we go through the, if we see the demo of that, so here's how the circuit looks like. And if we run through the command, run the command of that. So as you can see, the LED turns on as soon as I press the button, and it turns off as soon as I release it. So the after this, the next demo means, of course, the buttons are not the only types of inputs that you can give. There are the different types of sensors you can have, and sensors varies from different purposes that you want. So like you may have temperature sense to measure the temperature of the surrounding, or the humidity, or the pressure sensor that's used in the bank security pressure pads. So there are different kinds of sensors for different purposes. And let's go through the code of that. And eventually we'll see that how all of them come together, and you can build something new out of it. So like we have here, again the same thing. We mention the modules that are required. Then we have the board function. And inside that, we have this FSR, which is force sensitive resistor, which is essentially a pressure sensor. And we are defining it on the pin A0 analog pin. And we have also mentioned the frequency, means how frequently the sensor get the data. So here we have mentioned 25 milliseconds. And after this, we have what we have done is we have set a scale on the pressure sensor that the range of values it should return is from 0 to 255, and we'll just output that on the command terminal. And let's try to run that example. So here I'm just showing the glimpse of the code, and here is the circuit. I'm using the pressure sensor. And I just ran the program in the node, and you can start seeing that the values start coming, so 0, so nothing is spread. So I'm just showing how I'm pressing the pressure sensor to get the values, and you can see the change in the values as soon as it happens. Then I'm just trying to show both at the same time, pressing and getting the values. Next up, we have understood like how to show the output and how to get the input. So now let's try to connect both of them, and that's how the whole complete circuit works and they are built. So we are going to control the LED through sensors. So what we have done in the second video with the third video. Just going through the code of that. Can see, so we have the modules that are required. We have defined the sensors and the LED inside the board ready function. And this is the main section where we are working. So we have the sensor, we have set the range of values from 0 to 100, and whatever the data happens, so if the value is greater than 0, so if like in this case the pressure sensor, so if the pressure sensor is pressed and its value is greater than 0, this value changes. So LED will turn off, otherwise it will turn off. So look, just a simple logic like how you would almost whiteboard or like connect the Legos. It's similar to how that works. So just going through the videos of that, the demo of that. And here I'm going through the, gave the glimpse of the code, and here's the circuit we have. So we have the pressure sensor connected to the Arduino, and then we have the LED. So I just ran the command through the node. And you can see that as soon as I press the pressure sensor, the LED turns on, and it turns off as soon as I leave it. So, and you can see the change in the values on the terminal too. So there are a lot of things that has been happening in the space of JavaScript and IoT. So just giving a glimpse of a couple of projects. So this is a Jasper, which is controlling anything with your voice. So as they claim that you can build your own Javas. And I definitely recommend to try this out. Another project is NodeCopter, that is to fly your own drones using Node. And another project is HEME-Control.js, which is creating your home automation with Arduino or Raspberry Pi using JavaScript. And they also have a stack, NodeJS, MongoDB, HTML5, and WebSockets. So that's worth looking at. Another one. And the last we have the NodeBots. So the contributors of NodeBots have actually made the Johnny5 library. And this is another great project that you should check it out. So one of the personal project now I'll walk you through is like from the UX designing to the prototyping to development and testing. One of the things I built was an earthquake warning system. So the purpose was that if an earthquake happens anywhere, so the data, that warning signals, that has to reach to the citizens instantly within a second. And and I took it at a next step, like I wanted to build it for India. But there were a couple of hurdles that I came across. So there's this Indian meteorological website which has a page, which shows that the latest earthquake report regarding the where the recent earthquake came, what magnitude, the latitude and longitude. But because there's no API, I had to crawl every 10-20 seconds, and which was very inefficient way. And another thing that was doubtful was if an earthquake happened somewhere at like 6 p.m. and does it instantly get updated on the website? Like if it gets updated on 8 p.m., then that data is of no use. So I had to kind of build a whole system of like from a circuit point of view that can means the whole device which senses the earthquake and sends the data in real time. And because every second matters in a drastic event like earthquake and tsunamis. So I'll just try to show the demo of here, like how it works. And okay, just before going through the showing the video, let me just walk you through the code itself. So here what I'm using is with Johnny5 is PubNub, and PubNub is essentially a real-time data streaming library, and it claims that it can send data anywhere in the world within 0.25 seconds because they have that kind of a server and infrastructure. And that's what I'm using to send the data. And I'll be showing in the video that I have created a dashboard where it continuously, it's like a seismograph that the continuous tickers happens. So the changes will update on the dashboard instantly. So let's go through the video itself. Just before that, explain the code. So here we have the pubnub with a published key and subscribed key. So it's just like the WebSockets that happens, but on an enterprise level. So means using this, and on the board ready function, we have the sensor defined. And same as the before, we have defined the scale of like 0 to 10, just like in the Richter scale. And what the message will be sending through the pubnub is a JSON object with a key magnitude and the value, whatever the frequency that it senses. And in this case, I'll be replicating the earthquake effect using a pressure sensor, because like lightly you press, lower the value, harder you press, the higher the value. And after that, getting that value, we are just publishing to the pubnub, and this is a channel that we have created, earthquake_frequency, and the message is sent. And let's try to run the video of that. So I'm showing you the glimpse of the code. And this is a pubnub developer console. So here I can see the data that is going through a channel. So I'm just showing the channel, although it's a little blurry, but it's an earthquake frequency, just to make sure it's connected to the same channel that we have mentioned in the program. And here I'm using freeboard.io as a dashboard. So it comes with an inbuilt different components like a map, or this graph, or bar time graph, or different kinds of graphs, what you can ask for. So you can create almost all kinds of dashboards. And I'm just running the command, the node command. You can see that the values start coming, and I will, so just ensuring that it's the pressure sensor and the Arduino. And as soon as I press the pressure sensor, some values starts coming in, and they are being published to the pubnub channel. So as you can see the change in the value. And just to make sure, we'll go to the dashboard to see if the changes has come in or not. And just to ensure that it's actually working in real time. So it's a little difficult to show both the dashboard and this device at the same time, but it's working very it's instantly within a second. And to just double ensure that we are going through the developer console, that the messages are actually coming in, and you can see the change in the JSON object. So that was one of the my own projects where I thought through the designing to prototyping and programming and to testing it. Sorry? How do I power this? Okay, so right now I'm just using a 9-volt battery. Okay, but you can change it to whatever the power source. If you are deploying it in the on the field, okay, you may connect it to solar charger. Or there are now the boards are coming which are transmitting the messages through radio transmitter, which are longer range and the low battery consumption. So even with a 9-volt battery, it can run for a couple of months. So at the last, I just want to share you a couple of resources from different areas to get you started and get you interested in it. So one of the things is this JavaScript Robotics book by Make, which is actually teaches you to work with this Arduino and more using JavaScript, basically the Johnny 5. Then you can, of course, check out the Make magazines for more inspiration, like what projects you could pick up and work on upon that. There are tons of resources to work with the APIs. Some of them are Timbu, WebShell, Mashup, which is a library of a whole lot of APIs different languages, and IFTTT, which is if this then that. So I highly recommend it, and those are great resources, so you should check it out. Then there are also a couple of resources to work with the dashboards. There's Keen.io, then the Freeboard, which I just showed you, and the InfluxDB, which is database with dashboard. And for the sending the messages in real time, so there's a couple of real-time services are PubNub, Pusher, and Socket.io. And lastly, to work with the databases for the IoT, preferably are the NoSQL databases, so like MongoDB, Neo4j is a graph database, Parse, Firebase, which is a document database on cloud. And also I have attached a clipping of the article which shows how to make PubNub work with MongoDB through real time. And for more resources, you can check out my blog, and the source code of all these demos that I just showed you are available on that link, and also the slides. Plus, right now I'm working on creating a course on Udemy to work with JavaScript and Arduino, be it different libraries, be it Cylon or Johnify or Node-RED. And it will be updated on the GitHub profile, this same GitHub source code, as soon as it's released. And hopefully I'm planning to complete it by next month. And that's it. So any questions? Yeah. Yeah. Yeah, means it depends on the, yeah. Well, there are different strategies for basically first the need, means you are developing for the commercial or for your own, means okay. Mm-hmm. Yeah. Yeah, it's not. So for the commercial way, means right, actually I'm not the right person to answer that, because I just work with the, means I just tinker around with the problems and like create a prototype and make it work testing. Means I don't have an experience like to take it to a commercial level, so I may not be the right person to answer that. Yeah. Okay, thank you. Any more? Okay, so a little bit, you can actually order it online from their website, and otherwise you can just reach me out and I will get you in touch with them. Any more questions? Okay, thank you so much.